Action. And we're live. To all the math lovers around the world.
Yeah.
Anybody speak Brazilian? Portuguese, aka Portuguese. Yeah? How do you say hello?
Hola.
Oh, yes. Alright,
That's how you say it in Portuguese.
Yeah, I mean,
Yes.
it's related.
Portuguese.
Okay, the one person from Brazil that's watching.
Oh, that's good.
We try to make you up.
Let's go from Brazil.
Alright, here we go.
Shout out to
The sum of finite geometric series. We learned this last week. Remember the series, the sequence. We have these different terms, and the sequence just had us, find our R value, our common factor, and we multiply this term by the common factor to get the second term. We take the second term, multiply the common factor to get the third term. You guys remember this? Only a week ago. Now, that was sequences. It was all multiplication. Now today, geometric series adds the values in the sequence. Okay, so this idea just could be seen through like this example. If I need to walk to that trash can over there, but I can only walk half the distance every single time, tell me when to stop. I'm walking. Stop.
Oh,
Okay.
sorry.
Keep going. How about if I'm going to the trash can and I can only walk half the distance again? Where should I go?
the trash can.
Stop.
Oh,
Okay.
yeah.
Now the trash can's here. I can only walk half the distance. Where should I walk? Maybe like one step. Trash can's right here. Half. Right here. All right. Trash can's still there. Half the way there is going to be here. All right. Half the step from here to here is going to be there. Cut that in half. Cut that in half. Cut that in half. Cut that in half. I'd be inching towards this thing. Just never quite getting there, right? Because it's only half the distance every time.
So you can never touch it?
Well, theoretically, like in math logic, you would never touch it, but we have time as a constraint as well. Now, it would become so infinitesimal that it would practically be there. You'd practically be there. So all those steps, if I measured them all out, so I had one, or I started with a whole distance. I have half times a fourth, or plus a fourth, plus an eighth, plus a 16th, plus a 32nd. We'd eventually get all the way to where it's really, really close to 1, because that's an entire distance. But you see the idea that it could go forever, right? If I take one step, right, and then the next time I take 2 steps, and the next time I take 4 steps, right, I could keep going forever. That one's easier to see. It goes forever. Okay. Now we won't have to deal with that. That's more theoretical when we're talking about infinite geometric series. Finite, what does finite mean in comparison to infinite? A finite is?
Limited?
Limited. I like that. Limited. It ends. There's a start and a stop. Okay. So we are going to look at our geometric series, adding values, the finite geometric series. It's limited to the sum of certain number of terms. Now, some of this notation is kind of new. Who's seen this before? All right, Iris, what's this called?
Sigma.
Sigma. Okay.
Uppercase sigma.
Good. Uppercase sigma. We learned lowercase sigma was our standard deviation, right? It's just a different symbol. It doesn't mean these are related, and other than them being lowercase or uppercase Greek letter. Okay. So, what we know from the map, this is like our map. We know which position we start at. We know which position we're going to end at. We know our starting term, first term. Our common ratio is still R. It's the same as what we did last week. Common ratio is still R. And then it's K minus 1. Okay, K minus 1. It's easier to explore this and see it as we do a problem. So I'm going to just end by showing that if I was to say what this all means, like in words, it would be you take the sum from 1 to n of the series a sub 1 times r to the k minus 1. Just trying to get some syntax when you see it and you can read it to understand that. But that's for like the learners that are more written language learners. Maybe that's not you. I like to see it done out. Okay. I'm going to show you this, which is just to expand the sum, and then we're going to find the sum, the actual answer. Okay. So just to expand the sum, we start with this. Looking at this function right here, what's my variable? What's the thing that could change? 4 is not changing. 1/2 isn't changing. That's a constant. My variable is k. So essentially what we're going to do is, we know we're starting with our first term. We're going to end with the sixth. All I'm going to do is do this function where k is equal to 1, plus do the same function when k is equal to 2, plus do the same function when it's equal to 3. So when we have to expand, it's a little bit more to write out, but we don't have too many of those for homework because to really find the sum, the actual answer is what we're going for mostly. Okay. But knowing how to do this is helpful. I look at it this way, equals 4 times 1/2. And this is where I'm going to start with 1, and it's going to be 1 minus 1. Because the k value is the only thing we're substituting in. It's the only thing we're substituting. Plus 1/2, 2 minus 1. I want you on your own to figure out what's my third term here, or the third value for our sum. What are we going to add to next? What's next? Go ahead and write it out if you know. If you don't, ask your neighbor right off. Say, hey, I need a hint. All right. What group feels pretty confident? Any group showing confidence? Juan, what do you think?
The whole number or just the next?
Just read out. Yeah, 4 times
1/2.
1/2.
And then 3 minus 1.
3 minus 1.
Bless you.
Pretty straightforward. Again, the only thing that changed was what? The only thing that changed
Okay.
was k, because look up here, this is the only variable. All a sum is doing is, it gives you any function you have with a variable, and you just go between 1 and 6, 1 and 4, based on what these values are. It's 1 to 6. So we change that 1, we change that 2, we change that 3, and we're going to 6, so we better make sure you have a lot of space. 4 minus 1. 5 minus 1. 6 minus 1. Echo? It's cavernous in here. The classroom is so large. I'm hearing the echo. All right, so the series is going to be just the next step. Each one of these can be worked out. You guys know how to do this. What's 1 minus 1?
0.
0. Anything to the 0 power is?
0. 1.
Remember that? Remember that? This is really 4 to the 1/2 to the 0 power. That's 4 times 1. So we get 4 for our first term. How about the next sum here? 2 minus 1? 1. 1/2 to the first power is 1/2. What's
Plus 2.
4 times 1/2? 2. What's happening to these numbers?
Decreasing.
By what? What's our R? Right? Divide by 2. We can figure that out after we've seen it 3 times. 3 minus 1?
2.
2. 1/2 squared is really 1/2 times 1/2, which is
2. I mean 1. Wait. Yeah.
1/4. 1/4 of 4? 1. Are we following our R factors dividing by 2 every time? Or multiplying by 1/2, I should say. So we multiply by half. We multiply by half. And did we already know that? Yeah, we already knew that. Because this value right here that the exponent's already connected to, that's our common ratio. We already knew it was 1/2. We're showing this process even though we know that information. We're not depending on that. We're showing it through this process here. So I know this is going to be 1/2. This is going to be 1/4. I'll just go ahead and get all the way to it. When you have to expand the sum, you're just going to the expansion to know each term. You don't have to find the actual sum. Okay, so that's as far as you have to go for these type of problems. And really, everything is in here that you need. Starting value, that's our first term, a sub 1. That's my R value. K minus 1, as far as doing the sums, the K is the only thing that changes. Because that's the only variable. It's the only thing that can change. Okay. Thumbs up, sideways, down for doing this kind of work right here. Okay, mostly ups. Good. Good. Yeah. Okay. This is the main thing that we're going to use for a lot of the work you're doing. Okay. For this, the sum of the nth term, the actual sum, the value of adding all these together, is equal to a sub 1 times 1 minus r to the n over 1 minus r. Looks like a lot of variables, but if we go to these problems and we say, well, I just need to find a sub 1, r, and n, we could pull that out of this summation that we have. Okay, so let's go ahead and look at that. Everybody go ahead and rewrite the S of n is equal to a sub 1, 1 minus r to the n, 1 minus r. So once you have that written down, look at our summation right here. Look at our summation. And I want you to figure out what your a sub 1, your r, and your n are. And then I want you to check with your neighbor. Okay, so I'm looking at my summation. I'm pulling out the information. What's my a sub 1? What's my r? What's my n? Go ahead and jot that. Make a little note. And then once you've jotted those three values that we pulled out, so remember we're looking at this as a map. If I want to know a sub 1, I know it's that first number out in front being multiplied by my r value. So over there, that might be easy to see that way. I know it's a lot. So right now we're focusing on the summation here. We're going to use the sum formula. But all the information we need for the sum formula, if I know a sub 1, r, and n, I can find it. What is my a sub 1? Or check with your neighbor real quick. Double check they know what we're talking about. Yes. All right. Who's feeling confident? What group is feeling pretty dang hard?
2, 3, 5.
Okay. Where did you find the a sub 1? It's always that value that's first in line. We know it's right here next to summation. 2, r is going to be in the parentheses. R is always what the exponent is applied to. It's always r to some exponent. So look for the exponent. The value that is the base is our r value. What's our n? We're looking for the sum through the fifth term. From the first term to the fifth term. Okay. Now, looking at this, let's go ahead and I'm just going to pretend I have a smart board. And that's the 6th. That was my smart board sound. It's an old version. Yeah. Ready? We're finding the sum to term 6. All we have to do is work this out slowly. 1 minus 243. Negative 2. S is the sum of the series. The sub number here is our n value. So we're going the sum through term 6. Indeed. Would you like a Starburst for correcting me? Good job. All right. This is all from here on out. Once you plugged it in, this is stuff I'm confident you guys know how to do. I took the 5th power of 3. I got 243. 2's out front. I simplified the bottom. It's negative 2. And really, you can work it out slowly. 242 and negative 2. I want to check in right here. This is okay to do. I want to show you a bit of a trick here. Everything is multiplied together. You can think of it as kind of a system of circuits, right? If the negative is down here and there's another negative here, you can deal with those negatives as if it was just a negative times a negative, or a negative divided by a negative. Just because we have multiple values that are multiplied together or divided doesn't mean you can't cancel out right now. So what I can do is rewrite this as 2 times 242 over 2. What happened to negatives? Negative over a negative. It's not just at the final answer where you deal with the positive negatives. You can do it anywhere you want. If that makes sense, just know that that's one route you can take. Okay. It does make sense. Perfect. 2 over 2, can we get rid of that? can. 242. So the sum of the fifth term, this would be how I'd write my final. The sum S of 5 is 242. Straightforward. It's just different, right? It's just new, but it's not harder. You guys are really good at it this year. Don't get intimidated. All this is intimidating until you learn it. And then you forget why I was intimidated. And it can be sometimes. You see this in calculus, and it gets trickier. But you'll be ready for it then. Don't worry about it. Okay. Thumbs up, sideways down for the sum of the series. Find the sum. Pretty good? Okay. Let's go ahead and do the last one. This is the same thing. You didn't see that. So go ahead and find your a sub 1, r, and your n. Plug it in. Let's go and work it out. I'll let you guys work this one out all the way. Then double check with your neighbor and see if you can help them understand if they need it. All right. So let's work on this. We're doing number 3. Number 3 is going to be a good example to have. Number 3. Yes. Yes. Is everyone okay with me erasing this? Yes. Everyone? Sure? 1 sec. Okay. So what I'm going to do, while you're doing number 3 using the sum formula, I'm gonna solve it using expanding the sum. And I want you to see how they work together. You see what I mean? Okay, so we'll connect it that way. Tomorrow we'll actually derive the sum formula from the summation, which is going to be a little tricky. It's all right. We probably will do that tomorrow. All good, Jordan? Yeah. Okay. So you do it your way. I'm going to do it my way. You're going to do it using the sum formula. I'm going to do it the old way. You guys racing to the door. Oh, can you put the eraser in the door so it stays open, please? Thank you, sir. Okay, I just did it the other method. So double check if your sum formula method got you to that same place. It's kind of hard to see. I'm going to put it on the desk. Okay. Thank you. Shoot, don't fall. Okay, so you all were working it out using the sum formula. Who needs more time for sum formula? We're done? Good. Okay. What did I put in there for a sub 1?
3.
3. What should I put in for r?
2.
2. It's right here.
6.
2 dot
6.
6. 1 minus 2. I like your guys' method better. I mean, this was fun.
But it takes
I like that it being fun wasn't contested at all. It's fun when you know where you're going with this, what you're doing. What's 2 to the 6th power? 64? Thank you. 64, and this is -1. We're going to end up with 3, and we're going to end up with -63 and -1. It's going to end up being 3 times 63, which is 189. Very good. So we had that S sub 6. The sum until the sixth term is 189. You could see that if I sum it out and I make each term progress from 1 to 6 for our k factor, 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1. All those exponents get up to the sixth exponent. I work it all out. I kind of did some addition in a different way here. Got 189 as well. So it works. It works either way. Woo. That's some excitement in the back. All right. What should we say to those at home? What should we say? Don't breathe if you're in the Sacramento area. Don't go outside. It's challenging, but you know.
Don't breathe underwater.
The don't breathe challenge, not an ice bucket challenge. All right, how about subscribe on 3? Subscribe on 3. 1, 2, 3. Subscribe. Thank you. How do you say goodbye in Portuguese?
Adios.
Is it really? Ciao, ciao, ciao.